Hello everyone. Welcome to this live discussion session on ICSE 10th chemistry paper that was held yesterday for ICSE board students. So what are we going to do today in the session? We are going to discuss all the questions. What should be their ideal answers? I'm going to tell you that, and you will also get to know where you went right and where you went wrong. And for your future examinations, you'll get an idea how the ideal answers should be written. Before we actually start our discussion, quickly show me your presence in the chat box. Come on, everyone. Good morning. Type good morning if you're present there in the session. If I talk about the question paper was of moderate level. Most of the questions were the questions that we discussed in our day-to-day live classes, isn't it? We discussed about electro-refining of copper a number of times. We revised it. We practiced analytical chemistry, the colors of hydroxides a number of times during our live sessions. And all that came in the examination. The paper pattern was expected. It was similar to the ICSE sample paper that was released a few months back, and we practiced it in our live classes as well, isn't it? So I hope all of you did well in the examination and all your answers were correct. Just a few questions were tricky, so we will solve them together here. The number of numerical questions were not that much. Only 2-3 numerical questions were there. Questions from empirical formula and molecular formula were there. So all the chapters were given equal importance in the question paper as it was given equal importance in the sample paper as well. So when we were discussing about sample paper also during our live classes, I told you all that the paper pattern will be same and they are going to give equal importance. When you used to ask me, ma'am, which chapter is important, which is not important, which chapter to focus on more, I used to say that focus equally on all chapters, because it has been observed in the past as well that ICSE board gives equal importance to all the chapters in the syllabus. Okay, so are you all ready to know the correct and ideal answers to the questions? Come on, keep the chat box moving, show some energy, and also let me know how you feel your paper was, how you feel your answers went. Come on, everyone. Okay. That's great. That's great. Okay, so let's begin. First of all, I would like to discuss the instructions with every one of you. See, these were the instructions. The total maximum marks, like the total marks of the paper were 80 marks. And how much time was given to complete this paper? It was 2 hours. Okay, so you were supposed to answer all the questions in 2 hours, that is 120 minutes. And answer to this paper must be written on paper provided separately. You will not be allowed to write during first 15 minutes. So those 15 minutes were actually for reading the question paper. This time is given so that students can go through properly and decide what to write, what not to write, and they can frame answers in their mind. This is the reading time, and time given at the head of the paper is the time allowed for writing the answers. Section A is compulsory. Paper was divided into 2 parts, Section A, Section B. Section A contained 2 questions, out of which first question had 15 parts, and those questions were multiple choice questions. There were 4 options given to each question and you were supposed to select the correct answer from the given options. And then in Section A only second question was there. It contained different variety of questions like match the column and all. Then from Section B, you were supposed to attempt only 4 questions. Total 8 questions were there. So a lot of choice was available. Whatever question you must have felt that you can answer properly, you should have done that. Okay, I hope that you have selected the questions properly based on your knowledge and understanding, or whatever you were able to recall at that time. Okay, so out of 8 questions in Section B, only 4 questions you were supposed to do. The intended marks for questions or parts of questions are given in the square brackets against each question. So here in the instructions part, they do not give any detail of how many marks which question carries, but besides each and every question at the side in this kind of square brackets, the marks were written. I hope every one of you saw those marks and you gave the answers accordingly. Although the paper was very exhaustive and most of the answers were to the point, there were just a few questions in which you were supposed to write something in like language form or paragraph form or definition form. Otherwise, most of the questions were to the point and you were supposed to give to the point answers, equations, balanced reactions. Okay, so let's have a look at the first part of first question here. Okay, an element in period 3 whose electron affinity is 0. Okay, now this question is from the chapter in which we study about trends in the modern periodic table, periodic properties we studied. Okay, now if we think about electron affinity, it is the tendency to accept or say gain an external electron, isn't it? When we move from left to right in a period, what happens? The non-metallic character increases. Along with that, electronegativity increases and electron affinity also increases. Out of these given elements, neon, sulfur, sodium and argon. See, whenever you get a set of elements, first of all, you should try to figure out if they belong to same period or same group. If you have a look at this sodium, sulfur, neon and argon, okay, all of them do not belong to same period. Neon belongs to second period, sulfur, sodium and argon belongs to third period. So neon cannot be a correct answer because they are asking you to identify the element from period number 3 of the modern periodic table. So neon belongs to second period. Now out of sulfur, sodium and argon, the correct answer, dear students, here is argon, because it is a noble gas, it is an inert gas. If you have a look at the electronic configuration of argon, the electronic configuration for argon is 2, 8, 8. If you have a look at its valence shell, there are already 8 electrons present in its valence shell, isn't it? So its octet is already complete, and that is why noble gases are inert. They do not react with any other element. Their atoms do not form any kind of molecules. Okay, so the correct answer here is argon. Its electron affinity will be 0 because the atom of argon is not in need of electrons, not in need of gaining or losing electrons. Okay. Now moving to the next question. You can keep the chat box moving, keep commenting in the chat box. Okay. Here is the question. An element with the largest atomic radius among the following is? Largest atomic radius. Again, the question is from the chapter where we study about modern periodic table, the trends in modern periodic table, and now the property they want you to recall is atomic radius. What happens to atomic radius when we move from top to bottom in a group or left to right in a period? That you need to think before you find the correct answer to this question. Carbon, nitrogen, lithium, beryllium. Dear students, all of them are the members of which period? If you have a look at their electronic configurations, you will be able to figure out that they belong to second period of the modern periodic table. Largest atomic radius. When we move from left to right in a period, the atomic radius decreases. And if I talk about lithium, nitrogen, carbon, beryllium, they are like, first lithium will come. Then after lithium, out of this, after lithium, you will be able to find beryllium. When we move ahead, there will be boron. After boron will come carbon. Then there will be nitrogen. So the element out of these 4 elements which is placed at the leftmost side is lithium here. So the correct answer to this particular question is lithium. Out of these elements, it is lithium which is going to have the largest size, largest atomic radius. Okay, because when we move from left to right in a period, the atomic radius decreases. Okay, moving to the next question now. The compound that is not an ore of aluminium. To figure this out, either you need to just, like if you have mugged it up, then it is fine. Otherwise, you need to know the composition of these salts, the formula of these salts, then you can figure out. If I talk about cryolite, corundum, fluorspar and bauxite, out of these 4 salts, have a look at their compositions here. Fluorspar, cryolite, bauxite and corundum. These 3 compounds, these three substances contain aluminium in them. Bauxite is the chief ore of aluminium, but the other two are also ores of aluminium. Aluminium can be extracted from them as well. If you have a look at fluorspar, the formula for fluorspar is CaF2. It does not contain aluminium. So a mineral that does not contain aluminium can not be used as ore for aluminium. That is quite obvious. So the correct answer to this question is fluorspar here. Option C is the correct answer. Okay, moving on to the next question. And you can let me know how many questions out of the previous 3 questions you did correctly. Okay, quickly comment in the chat box how many questions you were able to do correctly. I guess, I hope all the 3 answers for you were the correct answers. Okay, moving on to the next question. The vapor density of CH3OH is, okay, you are supposed to find out the vapor density here. Vapor density, we can write it Vd for now. Okay. Now, what is the relationship between vapor density and molecular mass, or say molar mass, because that is what you are going to use here. The formula is known to you. The atomic masses are given there for your reference, and these elements are quite simple elements, initial elements in the periodic table. So I hope every one of you remember their atomic masses. Using the atomic masses, what you can do is you can calculate the molar mass, and then you can use the formula molar mass is equal to 2 into vapor density. Okay, you will rearrange the formula. How will you calculate molar mass? Using the formula 12 for carbon, 3 for hydrogen. Why I have directly written 3 here? Because 1 for 1 hydrogen and there are 3 hydrogen atoms. Okay, 16 for oxygen, 1 for hydrogen again. When you take a total of it, it comes out as 32. So molar mass here comes out as 32. When we put the values here, vapor density will come out as 16. So the correct answer to this question becomes option C. Okay, now moving on to the next question. Which of the following reactions takes place at anode during electroplating of an article with silver? Okay, whenever we electroplate any article with silver or nickel, what we do? We place that article at cathode, and at anode we place the rod or say block of the metal with which we are doing electroplating. So here if we are electroplating an article with silver, we will use silver at anode. Okay, and at anode what happens? At anode oxidation occurs. Oxidation is the process of loss of electrons. Okay, whenever any chemical species loses one or more electrons, it is said to be oxidized. Anode is the positive electrode. It has the capacity of taking electrons, so oxidation occurs at anode. So what will happen at anode? Actually option A is the correct answer here. The silver atoms from the block of silver or rod of silver, whatever we are going to use, will keep losing one electron. They will keep converting to silver ions. These silver ions will keep moving to the solution and they will move to cathode and get converted to silver metal that will get deposited over the surface of the cathode, which is the article to be electroplated. So this is how one complete layer of silver will be formed over the article which is placed at cathode for electroplating. So which reaction takes place at anode? Oxidation reaction occurs, and here the correct reaction is loss of one electron from silver atoms and they get converted to silver ions, which is Ag, that is silver atom with a single positive charge. Okay, so correct answer to this question is option A. Come on, quickly tell me in the chat box how many answers you got correct till now. Come on everyone. Keep the chat box moving. Okay, that's great. That's great. Very good. So, shall we move to next question? I hope and you are enjoying the session and you are also excited to know the answers to the upcoming questions. Next question is the metallic hydroxide which forms a deep inky blue solution with excess ammonium hydroxide solution is. Read the question again. This question is from analytical chemistry and the colors and the reactions here with NaOH, NH4OH, that is ammonium hydroxide, are quite confusing, isn't it? That is why I advised you all to revise it several times. 2-3 questions came from this colors of hydroxides in this particular paper. Okay, metallic hydroxide, which forms a deep inky blue solution with excess of ammonium hydroxide is. Dear students, the correct answer here is option B, copper hydroxide. Actually, copper hydroxide, it reacts with ammonium hydroxide. When these copper hydroxide precipitates, which are pale blue in color, are obtained on reaction of any copper salt with a small amount of ammonium hydroxide solution, these precipitates are obtained. When you try to dissolve them in excess of ammonium hydroxide, a reaction occurs which results in formation of tetraamine copper complex. This is tetraamine copper complex here, and this is a complex compound with a deep blue color, deep ink-like blue color. So due to formation of this compound, it is copper hydroxide which produces a deep inky blue solution when we dissolve it in excess of ammonium hydroxide. So correct answer here is option B. Okay, let's move to next question. An example of a cyclic organic compound is, we have studied that organic compounds can either be open chain, they can be branched, like branched compounds also fall into the category of open chain compounds, and they can be closed chain compounds. Closed chain compounds, that means ring compounds, cyclic compounds. Out of the given options you were supposed to identify the cyclic compound. Have a look at the names. Okay, propene, pentene, butene, all these three are alkenes, and these are open chain alkenes. Propene 3 carbon chain will be there, pentene 5 carbon chain will be there, butene 4 carbon chain will be there. But what about benzene? Dear students, this is the structure of benzene. It is also an unsaturated hydrocarbon. It is cyclic hydrocarbon. So the correct answer to this question is option D, benzene. These three are open chain compounds. This is the cyclic compound. Benzene is also, like, it falls into the category of aromatic hydrocarbons. Okay, next question is, in the laboratory preparation, HCl is dried by passing through. Okay, which drying agent is used to dry HCl during its laboratory preparation? Nitric acid, concentrated sulfuric acid, dilute sulfuric acid, acidified water. Acidified water means small amount of sulfuric acid mixed with water. So here I am pretty sure, like, this was a very easy question. Every one of you know that concentrated sulfuric acid is a very strong drying and dehydrating agent, isn't it? It helps in water removal, like chemically bonded water, as well as just the moisture which remains associated with substances. So the correct answer here is option B, concentrated sulfuric acid is used. Okay, and this concentrated sulfuric acid has one added benefit. It is non-volatile in nature. It does not evaporate. So its fumes will also not mix with the HCl gas. So the preferred drying agent here is concentrated sulfuric acid. Next question. The nitrate which on thermal decomposition leaves behind a residue which is yellow when hot and white when cold. Okay, so two things should come to your mind when you read this question. Nitrate which on thermal decomposition, first of all, it is a nitrate salt. Okay, although in the options also all the nitrates are given. Now you should know what happens when a nitrate salt breaks, when it undergoes thermal decomposition. Okay, and the residue, like the product obtained after decomposition, should be yellow when it is hot, and its color should change when it cools down. This property of color change is shown by zinc oxide. Okay, and zinc oxide is obtained on thermal decomposition of zinc nitrate. When zinc nitrate is heated, it breaks to form zinc oxide. Nitrogen dioxide gas is given out, NO2 gas is given out, and oxygen is given out. This nitrogen dioxide gas is brown in color, so you will be able to see brown fumes coming out of the test tube, isn't it? And here this ZNO, which is like the color change is shown by this zinc oxide. So the correct answer here is option D, zinc nitrate. Okay, moving on to the next question. The salt formed when concentrated sulfuric acid reacts with potassium nitrate, KNO3 is potassium nitrate, above 200 degrees Celsius. Chemical reaction based question it is. You should be able to recall that what kind of reaction occurs and what is the product obtained when sulfuric acid and concentrated sulfuric acid and potassium nitrate are made to react with each other above 200 degrees Celsius. Sometimes the product changes with change in temperature at which reaction is carried out. That is why they have mentioned specifically above 200. So that should also strike your mind. Okay. So if you were able to recall the correct answer to this particular question, would have depend, or say it depends on how much revision you did, how much practice you did for the reactions. I always used to say that practice reactions again and again, focus on the reaction conditions, focus on the color of the products which are forming and any other special point which is related to that chemical reaction, because questions can be framed from all the associated points as well. Okay. So dear students, the correct answer here is potassium bisulfate, option C, KHSO4, because when this KNO3, okay, wait. When this KNO3 reacts with concentrated sulfuric acid at above 200 degrees Celsius, it results in formation of potassium bisulfate, and HNO3 is also, like nitric acid, is obtained as one of the products. Okay, correct answer here is option C, potassium bisulfate. Okay, moving on to the next question. The property exhibited by concentrated sulfuric acid when it is used to prepare hydrogen chloride gas from potassium chloride. Okay, the property exhibited by concentrated sulfuric acid. Again, the question is on the preparation of hydrogen chloride gas. Chapter 8, part like hydrogen chloride, part of that particular chapter. From that it is preparation of HCl. So when it is prepared from potassium chloride, actually sulfuric acid is used, and nitric acid will also give the result, but we do not use nitric acid. Which property makes it suitable, makes sulfuric acid suitable for this particular use? Why we give it preference over nitric acid? That you should be having in your mind when you are trying to find correct answer. Yes, I agree that sulfuric acid is dehydrating agent, drying agent. These two properties are utilized when we dry HCl gas using concentrated sulfuric acid. But when we prepare it, actually it is option D, the non-volatile acid property of sulfuric acid, which is demonstrated over there. The fumes of sulfuric acid will not mix with the HCl gas. And otherwise, if you use nitric acid, what will happen? The fumes of nitric acid will mix with HCl and you will get a mixture of HNO3 and HCl as the product. Okay, so being non-volatile in nature makes it suitable for use in this particular preparation. Option D is the correct answer to this particular question. Okay, quickly show me your presence in the chat box. How many answers you got correct till now? I'm able to see your comments here. Yes, your answer is correct. Honey, hydroxide. Hydroxides are the salts which contain OH group. See, this is OH with a single negative charge. Okay, sorry, OH with a single negative charge. This is hydroxide ion. Okay, whenever in any salt this hydroxide ion is present, we call it hydroxide, like sodium hydroxide. This is the hydroxide of sodium metal. So this is also a metal hydroxide. For example, calcium hydroxide, CaOH whole twice. Okay, so this is also metal hydroxide. So hydroxide ion, which if it is present in any salt, it is the hydroxide salt. Okay, how many answers you got correct till now? Tell me quickly. Everyone, keep commenting in the chat box. Keep it moving. Show me some energy and tell me how many answers you got correct till now. I hope all your answers were correct. Okay, so let's move ahead and let's move to next question now. Okay, hydrocarbon formed when sodium propanoate and soda lime are heated together. Sodium propanoate is actually an ester. Okay, it is one of the classes of the organic compounds, and you have to predict, or say you have to give the correct answer about the product which is formed when sodium propanoate and soda lime are heated together. Is it methane, ethane, ethene or propane? Dear students, the correct answer here is ethane. Actually, this is the formula for sodium propanoate. When you heat it with soda lime, okay, soda lime is a mixture of, I'm sorry, soda lime is a mixture of sodium hydroxide and calcium oxide, okay, NaOH and CaO. So, soda lime, like it is obtained by mixing these two substances, you should know that. And when we heat the sodium propanoate, reaction takes place in this, ethane is formed, okay. This is not one of the products. This sodium hydroxide and calcium oxide is like soda lime here. Sodium carbonate is one of the products and ethane is one of the products. So out of the given options here, the correct answer is option B, okay. Let's move to next question. The general formula of hydrocarbons with single covalent bond is. First of all, what should come to your mind as soon as you read this question? Single covalent bonds. This is the property of alkanes, isn't it? The saturated hydrocarbons. In these hydrocarbons, all the carbon atoms remain connected to each other only through single covalent bonds, isn't it? So, saturated hydrocarbons, basically you were supposed to identify the general formula of alkanes. Very easy question it was. You must have got confused with this option D, which like this is the general formula for which kind of hydrocarbons, isn't it? Otherwise, it is quite easy for you all to identify. We have studied it and revised it several times. The correct answer here is option A, CnH2n plus 2. CnH2n is for alkenes, CnH2n minus 2 is for alkynes, and here this CnH2n minus 6 is for aromatic hydrocarbons. Please remember. Okay, this is for aromatic hydrocarbons. Like benzene. What is the formula for benzene? Anyone who knows it, please type in the chat box. Please comment what is the formula for benzene. The formula for benzene is C6H6. Okay. Now, if you try to expand the formula of benzene in this particular form, you will be able to do it. See, this is C6H6 into 2. Okay, N is equals to number of carbon atoms, na? So, 6 into 2 or 2 into 6 minus 6. So, 12 minus 6 will give you 6. Okay, so this is like one of the examples. Aromatic hydrocarbons have this particular general formula. Moving on to the next question. Again, very easy question it is. It is from the chapters acids, bases and salts. And from this chapter, the topic of indicators, isn't it? The indicator which changes to pink color in an alkaline solution is. Different indicators produce different colors when they come in contact with acidic and basic substances. Blue litmus, methyl orange, red litmus, phenolphthalein. Out of these 4 given, which will give pink color with a basic solution? I hope every one of you know the answer to this. It is phenolphthalein. Okay, not option A. Option D is the correct answer. Phenolphthalein is the correct answer. Phenolphthalein turns pink in alkaline solution. Originally, phenolphthalein is colorless and phenolphthalein remains colorless when it comes in contact with acidic solutions. Okay. So, in acidic solutions, phenolphthalein will remain same, colorless, and in basic solutions, it will turn pink. What about methyl orange? How many of you know which color methyl orange produces when it comes in contact with basic substances? Originally, methyl orange is orange in color. That is why we call it methyl orange. Okay, come on, tell me in the comment section quickly which color is obtained when methyl orange comes in contact with basic substances. It turns green in color, isn't it? Blue litmus will remain blue and red litmus will turn to blue. So, pink color is associated with phenolphthalein. Correct answer here is phenolphthalein, option D. Okay, let's move to next question. Now, question 1 is completed. We are moving to second question. Okay, first part of the second question was match the column. You were supposed to match like names of the various substances given in column A with one of their properties in the column B. It was just name of one reaction also here. Okay, sodium chloride, methane, hydrogen chloride, oxidation reaction and water. Out of like 6 options were given in column B, so one was extra. Okay, that was there to confuse you actually. Has 2 shared pair of electrons, has high melting and boiling point. High melting and boiling point is a property associated with ionic compounds, electrovalent compounds, isn't it? So this sodium chloride here is an electrovalent compound, ionic compound, so A matches with 2. Methane, dear students, is a greenhouse gas. Hydrogen chloride, oxidation reaction, water. Okay, water has 2 shared pair of electrons. You might be thinking that hydrogen chloride is also a covalent compound, but if you think of hydrogen chloride, you will be able to recall that there is just 1 shared pair of electrons in between hydrogen and chlorine in hydrogen chloride. And here the first point in column B says has 2 shared pair of electrons. It is actually water. So E matches with 1 here. Oxidation reaction. I told you a few minutes back that oxidation is loss of electrons. So out of given these 2 reactions, the reaction in which loss of electrons is happening, this zinc is converting to zinc ions, cation. This is oxidation. And hydrogen chloride gas actually has low melting and boiling points. That is why it is gaseous at room temperature. Okay, so what is the correct answer here? A was matching with 2, B was matching with 3, C with 4, D with 5 and E with 1. Okay, so this should be the answer that you gave in your answer sheet, that you wrote in your answer sheet. Okay, very good Abhyuday, you were able to score 14 out of 15 in the MCQ section. That is really a great score. Very good, congratulations, and I hope in the upcoming questions also you did great and you will be able to score really good. Very good. Okay, let's move ahead and let's move to the second part of second question. Okay, this particular question was from the extraction of aluminium, electrolytic reduction of aluminium it is actually, isn't it? Looking at this diagram, what should come to your mind? Electrolytic reduction of alumina, obtaining aluminium through the process of electrolysis from alumina. Okay, the process is known as Hall-Héroult's process, isn't it? So, based on this particular diagram, they see, this is the electrode which is connected to the positive terminal of the battery, and the negative terminal of the battery is connected to this electrolytic tank. Actually, in this process, there is an inner carbon lining which is present in the electrolytic tank, and it is acting as cathode here. So, keeping all this in mind, analyze the diagram properly, and based on that, you were supposed to give the answer to the following questions. Okay. Very good, Abhyuday. Okay, Lata. Okay. Name the constituents of the electrolyte mixture which has a divalent metal in it. Okay. Name the constituents of the electrolytic mixture which has a divalent metal in it. See, you will have to think of the composition of this electrolytic mixture here. How many of you know this? You can comment in the chat. In the comment section, you can comment. How many of you are aware of the composition of electrolytic mixture here? Electrolytic mixture is not just molten alumina. I hope every one of you remember that. There's a very there's an issue with the melting point. Melting point of alumina is quite high. So to reduce its melting point and for different purposes, several other substances are also mixed in this electrolytic mixture, isn't it? So it is a mixture of alumina, cryolite, fluorspar, and coke is also sprinkled over this electrolytic mixture. Out of these, it is actually fluorspar that contains divalent metal. I'll show you. The next question is, name the powdered substance X is sprinkled on the surface of electrolytic mixture. I just now told you it is coke. Okay. What is the name of the process? Name of the process is Hall-Héroult's process. See, fluorspar, CaF2. Divalent metal here is calcium. The valency of calcium is 2 and it forms calcium ions. Okay, a divalent cation. Coke is sprinkled over electrolytic mixture to protect anode from burning. And Hall-Héroult's process, this is the name. And what was the fourth question here? Write the reaction taking place at the electrodes Y, and Y is the name given to anode and Z is the name given to cathode. So at Y, what will happen? I told you at Y, at anode, loss of electrons occur. Okay, so anode here will be impure block of, Anode, at anode what will happen? These aluminium here will be obtained at cathode. Okay, moving on to the next question. Lata is writing something there, but I am not able to understand. Okay. Next, fill in the blanks with the choices given in the brackets. Okay, you were supposed to pick the correct words from the given options in the bracket and fill in the blanks. Metals are good. Oxidizing agent, reducing agents. Okay, metals have a property of losing electrons, and by providing electrons, metals actually help other substances to other chemical species to get reduced, and that is why metals act as reducing agents here. Non-polar covalent compounds are bad conductors of heat and electricity. Higher the pH value of a solution, the more higher the pH value, more will be its alkaline strength. Okay, so here it is alkaline, it is bad. For it, first one it was reducing agent. Okay, next one, you were supposed to remember the solubility of the salts in this case. Silver chloride and lead chloride were the options. Is a white precipitate that is soluble in excess of ammonium hydroxide. The correct answer to this one is silver chloride, because if you will mix lead chloride with ammonium hydroxide, it will react to form precipitate, white color precipitates of lead hydroxide. Okay, so lead chloride will react with ammonium hydroxide, but this silver chloride will dissolve in it. So correct answer to this is silver chloride. And conversion of ethene to ethane is an example of ethene to ethane, unsaturated hydrocarbon converting to saturated hydrocarbon. Unsaturated hydrocarbon converting to saturated hydrocarbon. Hydrogen is being added there. What are the options given? Hydration and hydrogenation. Please do not get confused in between hydration and hydrogenation, because hydration is the term given to the process of addition of water. Dehydration, removal of water; hydration, addition of water. Similarly, hydrogenation is addition of hydrogen to a substance, and dehydrogenation is removal of hydrogen from any substance. So the correct answer here is hydrogenation. I hope all your answers were correct. You can let me know in the comment section if you are able to score full out of full in this particular question or not. See, I was talking about the marks that were mentioned in square brackets. This is how the marks were mentioned in the question paper. Moving on to the next part of the question number 2. State the terms / processes for the following. State the terms / processes for the following. So what you were supposed to do in this particular question, you were supposed to read the statement and figure out what is the term given to it. Okay. Yes, Abhyuday, maybe if the teacher considers. Okay. The energy released when an atom in the gaseous state accepts an electron to form an anion. The energy released, I hope every one of you know that the process of gain of electrons is exothermic in nature. And there's a specific term given to that energy which goes out. Okay, it is known as electron gain enthalpy. Okay, what do we call it? We call it electron gain enthalpy. Tendency of an element to form chains of identical atoms. This property is shown by carbon, like to the maximum extent. So this is catenation. Name of the process by which ammonia is manufactured on large scale, Haber's process. Type of salt formed by partial replacement of hydroxyl radicals with an acid radical. See, if there is a salt, okay, and you have a base, and from that only partial replacement of hydroxide ions is taking place, you will get a basic salt. And the ratio of the mass of a certain volume of gas to the same volume of hydrogen measured under the same conditions is known as its vapor density. You might have found these two a little difficult, but the initial three were quite simple. Okay, moving on to the next part of question number 2. This particular question was from IUPAC naming and the structures, like completely based on IUPAC naming. Looking at the names, you were supposed to draw structures. Looking at the structures, you were supposed to write the names. How many of you were able to do it? In our live classes, we practiced it several times, isn't it? Even the doubt session, the practice session that we kept just a day before your examinations, in that also in 50% of time we did this only, isn't it? You were asking me to give the practice of IUPAC naming and how to draw structures. I hope you were able to do it properly. Come on everyone, let me know in the comment section if you are able to write the names and draw these structures properly. Then I'll draw these structures for you. Actually, I have already drawn them. I'll show you and I'll tell you why that is correct and why other structures will be incorrect. Okay. So the first one here is 2-chlorobutane. See, I told you whenever we draw structures, we start with the root word. Root word here is but. So what we'll do is, to make the structure of 2-chlorobutane, we will make a chain of 4 carbon atoms. We'll number the carbon atoms and 2-chloro it is written there, isn't it? 2-chlorobutane. So but, 4 carbon atoms, 2-chloro means chlorine atom at second carbon atom, and ane here tells you that all the bonds are single bonds in between the carbon atoms, no double bond, no triple bond, saturated hydrocarbon it is. So this is the structure for 2-chlorobutane. The next one here was methanol. See beta, after reading the name of this particular compound, AL, this suffix at the end will give you the idea of the functional group present in it. AL stands for aldehydic functional group. Okay, and meth is the root word for 1 carbon atom. Okay, and you know that any functional group which contains carbon of its own, its carbon has to be given number. So here the formula for methanol will be HCHO and it will not be CH3CHO. If someone has written this as the structure or say formula for methanol, this will be incorrect because there are 2 carbon atoms here. The carbon of the functional group is also given number, and when it is methanol, meth means 1 carbon, that will be the carbon of the functional group, and just 1 H will be there. Okay, and what was the third one here? But-2-ine. But 4 carbon atoms, 2-ine means a triple bond after third carbon atom. Okay, so this should be a triple bond here. You number the chain from any side, it will be correct. 1, 2, 3 and 4. After second carbon, there is a triple bond. So it becomes but-2-ine. Okay. Got it? Now, the next one is you are supposed to write the names of these compounds. IUPAC names. See, first one is a carboxylic acid here. 1 and 2. This is ethanoic acid, and this one here is, see, you can see alcoholic functional group attached to. I think I will be numbering it from this side because from this side the functional group is nearby. So 1, 2, 3 and 4. Okay, and for this functional group the suffix is all, OL, all I am going to use. So this is butanol, and at which position this OH is present? At second position. So you can write it as 2-butanol or you can write it as butane-2-ol. Both the names are correct. Okay. So ethanoic acid and butane-2-ol, or you can write it as 2-butanol. Both of them are correct. If someone has written it as 2-butanol, that is also fine. Come on, quickly let me know in the comment section how many answers you got correct till now. What is your score up to this point? Then we'll start solving question number 3. Come on. Come on, everyone. Okay. Okay, that's great. Let's move to question number 3 now. Identify the cation in each of the following cases. Now, what you were supposed to do in this question? In this question, dear students, you were supposed to identify the cation that will be present in that particular solution responsible for a specific property or color. Okay. When we take ammonium hydroxide solution and add it to solution B, which gives white precipitate which does not dissolve in excess of ammonium hydroxide. Again, this question is from chapter Analytical Chemistry. Actually, the precipitates of lead hydroxide. This solution B must be a solution of any lead salt. When you make ammonium hydroxide solution react with a lead salt, we obtain precipitates of lead hydroxide which are white in color. So white precipitate, this matches, and does not dissolve in excess of ammonium hydroxide. So it is lead hydroxide and lead ion. What should be your answer? Actually, this is the precipitate. Okay, and from this precipitate, or say this precipitate is formed because of presence of lead ion. These lead ions will come from solution B. You were supposed to identify the cation here. So the correct answer here is lead ion. Even if you have written just lead ion there in language, that would be fine. If you have written it like this, that would be fine. There was no need of this description. But if you have given it, it is fine. I have added to improve your understanding about it, why it is correct. Sodium hydroxide solution when added to solution C gives a white precipitate which is insoluble in excess of sodium hydroxide. Okay, white precipitates are obtained in 3 different cases when we make different salts react with sodium hydroxide. I hope you remember. Lead salts, zinc salts, as well as calcium salts. These 3 types of salts on reaction with sodium hydroxide gives you white precipitate. Calcium hydroxide, lead hydroxide and zinc hydroxide will be obtained. Zinc hydroxide and lead hydroxide are soluble in excess of ammonium hydroxide, so they cannot be the correct answer. Calcium hydroxide is insoluble in excess of sodium hydroxide, so the correct answer here is CaOH whole twice. And the cation that you were actually supposed to identify, this calcium hydroxide will form because of presence of calcium ions in that solution, isn't it? So the correct answer is calcium ions here. Okay. Moving on to the next question. Fill in the blanks by choosing the correct answer from the brackets. During electrolysis, the compound in its molten state liberates reddish brown fumes at anode. Okay, out of NaCl and PbBr2, that is lead bromide. PbBr2 is the formula for lead bromide. Out of these 2 salts, if you carry out their electrolysis in molten state, what will be the products at anode? At anode, it is the negative ions that will go. Okay, so from sodium chloride, chloride ion will go to anode, and that will form chlorine gas. Chlorine atoms will be formed. Chlorine atoms will combine with each other to form chlorine gas, which is yellowish green in color. It is not reddish brown in color. PbBr2, out of lead and bromide, bromide ions are negative ions that will move to anode during the electrolysis process, will convert to bromine atoms will combine to form bromine gas, and reddish brown fumes of bromine gas it is. So out of these 2, the compound that will be able to liberate, or say during electrolysis of molten, which salt during molten state reddish brown fumes will be evolved? Lead bromide. So the correct answer to this is lead bromide. At anode, bromine gas will be formed. Okay. The ion which could be discharged most readily during electrolysis is out of given 2 options. Ferrous ions are there, Fe with 2 positive charges, and cupric ions are there, Cu with 2 positive charges. To find the correct answer to this, you actually need to know the position of these ions in the electrochemical series. Okay, lower the position of ion in the electrochemical series, easier for that ion to get discharged, or say it gets preference because it is easier for it to gain electrons. Actually, see, Cu2 plus ions are placed at a lower position than ferrous ions in the electrochemical series. What does that mean? Actually, this difference arises due to difference in the electropositivity of iron and copper. Copper is less electropositive than iron. Hence, copper ions will gain electrons more easily, more readily as compared to ferrous ions during electrolysis. Okay, so the correct answer here is copper ions. Moving on to the next question. What you were supposed to do in this question, you were supposed to arrange the given elements in a specific order according to the instructions that were given in the brackets. Okay, aluminium, potassium, magnesium and calcium, decreasing order of reactivity. To find the correct answer to this question, you should know their positions in the periodic table, as well as you should know in which direction the reactivity of metals increases and in which direction the reactivity of metals decreases. Okay, so you can comment that quickly in the comment section in which direction, what happens when we move from top to bottom, what happens when we move from left to right to the reactivity of metals, okay, in which direction the reactivity of metals increases, because that is what going to help you arrange them in the decreasing order of their reactivity. See, if I draw like just a symbolic image of periodic table here, I think this much is sufficient to place these elements. Okay, potassium, this is lithium, sodium, and here will be potassium, K. Okay, here we will have calcium. Here, after sodium, you will have magnesium and boron, and here it is aluminium. Okay. No, aluminium is not here. Wait. Aluminium is above it. Okay, after figuring out the positions, what you will be able to do? You will be deciding on moving from top to bottom, what happens, the reactivity increases. And on moving from left to right, what happens, the reactivity decreases. So the metal which is at the rightmost side will have the minimum reactivity. Okay, so aluminium will have the minimum reactivity. Coming towards the left, out of magnesium and calcium, calcium will be more reactive, magnesium will be less reactive, and potassium will be most reactive. So the increasing order will be potassium, then calcium, then magnesium, then aluminium. You could have solved this question if you do not know the position of these things and you do not remember the trends in the reactivity of metals. You could have done this using your knowledge of the reactivity series of metals. Okay. If you have a look at the positions in the reactivity series also, you will get the same order. So the correct answer here is this one. Next is increasing order of non-metallic character. When we move from left to right in a period, the non-metallic character increases. If you have a look at the elements given here, nitrogen, beryllium, oxygen and carbon, all of them belong to second period of the modern periodic table. Okay, so you just need to know the way they are present in the second period, which element comes first, which comes after it, and based on that you can do it. Beryllium comes first, beryllium is a metal, then comes carbon, then comes nitrogen, then comes oxygen. So the highest non-metallic character will be in oxygen. You were supposed to arrange in increasing order, so oxygen will come at the last, beryllium will come at the first. So smaller to larger you are going, increasingly you are arranging them. Phosphorus, silicon, fluorine and beryllium, decreasing order of valence electrons. To know this, you either need to know their group number or their electronic configurations through their atomic number. 7 valence electrons are present in fluorine. In silicon there are 4, in phosphorus there are 5, and in beryllium there are just 2. So you were supposed to arrange them in decreasing order of valence electrons. 7, 5, 4 and 2. This becomes the decreasing order of valence electrons. I hope every one of you were able to do this with any of the logics. Okay. In each of them, actually, there were 2 different logics that were working. So I hope every one of you got right. Okay, Abhyuday is saying, ma'am, I had written silicon before phosphorus. Will I get half mark for writing correct place of fluorine and beryllium? I don't think so, Abhyuday. I'm really sorry. But this was a very small thing. Na? Just for 1 mark, you were supposed to give 1 correct order. The order gets disturbed if you switch the position of any 2 elements with each other by mistake. So this answer will be wrong, but no problem, it's okay. All the other answers, or say most of the answers you are getting correct, so don't like get nervous or sad. It is fine, it's okay, it happens sometimes. Okay, but for this definitely you are not going to get any marks. Next one, question number 3, 4th part. Complete and balance the following equations. So again, based on chemical reactions, this question was, you were simply supposed to figure out what will be the products, and after figuring out the products, you were supposed to balance the chemical equations. Okay, so when ammonium chloride reacts with calcium hydroxide, it results in formation of calcium chloride, ammonia and water, and this is the balanced chemical equation. Second was, what happens, or say what are the products formed when copper sulfate and ammonium hydroxide react with each other. They result in formation of copper hydroxide and ammonium sulfate, and this is the balanced chemical equation. See, balancing chemical equation is quite simple. You simply have to make the number of atoms of each kind equal on both the sides of the equation. And the third one given here was copper reacting with concentrated nitric acid. When any metal reacts with concentrated nitric acid, it is a salt formed, nitrogen dioxide gas is given out, and hydrogen formed in the reaction is actually oxidized to water, isn't it? This is why we remember the reactions with nitric acid so prominently. Okay, And that is what they were checking when they gave you this reaction to write. Okay. Ma'am, can we write NH4OH instead of NH3 plus H2O in subpart A? Okay, that may be considered, because definitely if water and ammonia are formed together in a reaction, they are going to react and form ammonium hydroxide. So there are chances that they will consider and give you marks. Shreya. Let's hope for the best. Okay. Moving on to question number 4 now. Okay. State a relevant reason for the following. Hydrogen chloride gas cannot be dried over quicklime. Hydrogen chloride, its preparation, its drying was given a lot of importance in the question paper, isn't it? This is the third question we are seeing based on the laboratory preparation of HCl and what are the different drying agents, dehydrating agents which are used for drying of this HCl, isn't it? So, we know that we use concentrated sulfuric acid to dry HCl gas. Why not quicklime? Quicklime is also a very good drying agent, but why don't we prefer it? Any one of you know the answer? Type in the comment section quickly. And the second one was ammonia gas is not collected over water. Quite simple it was, isn't it? See, HCl actually reacts with calcium oxide. Quicklime is what? Quicklime is nothing but calcium oxide, CaO. Okay. Now you might have faced the difficulty if you were not aware of the composition of quicklime. Chemically what it is? Chemically it is calcium oxide. It reacts. HCl reacts with calcium oxide to form calcium chloride and water. Even if you say that calcium chloride has somewhat drying properties, but the substance that you are drying is no more available. So you will not obtain, you will not be able to collect this HCl. So it cannot be done. You should always use drying agents which do not react with the substances that we are drying out. Okay. And ammonia is not collected over water because it is highly soluble in water. If you try to collect ammonia over water, it will keep reacting and you will not get ammonia gas. Okay. Okay, very good. See, there is one more explanation that is given by Aishwarya here. Hello Aishwarya, good to see you in the session. So, HCl is acidic in nature and CaO is basic in nature. An acid and a base will definitely react with each other to form salt and water. That is how also you can look up to it. And yes, Abhyuday, you are correct that ammonia is highly soluble in water, hence cannot be collected over water. Okay, moving on to the next question now. I hope every one of you is able to keep up with the pace of the session and you are able to evaluate what you did wrong, what you did correct. Okay, after the session, like towards the end of the session, you can also try to predict how much you get and later on you can match. Okay, this will be a fun activity. See, after you have already given examination, you should not be worried about your marks. You should only be just figuring out what you did right and what you did wrong and if there is any silly mistake that you made. Okay, otherwise worrying about result after giving examination is of no use because you have already written the answers. Now, no matter how much you worry, it is not going to help you in any way. So just solve the question paper with me, with fun, just to figure out how much you are going to score. Okay. Next question is right there for every one of you. Identify the alloy in each case from the given composition. So from the composition you were supposed to identify the alloy. This question was from metallurgy, isn't it? And metallurgy, like previously also extraction of aluminium, one question came from this chapter. Aluminium, magnesium, manganese and copper. Come on, give me the answer in the chat box. Very good, Aishwarya. Very good. First correct answer in the comment section is given by Aishwarya here. So it is duralumin, alloy of aluminium. Aluminium is present in maximum quantity. Other metals are present in small quantities to improve the properties. The second one is quite simple. It is iron, nickel, chromium, carbon. Very good, Abhyuday. 38 out of 14 section A. Very good. That is excellent for both Aishwarya, Abhyuday, and others can also let me know. Update me, keep updating me, keep the chat box, the comment section moving. Yes, come on, tell me. Very good. It is stainless steel, isn't it? The difference between stainless steel and steel we have discussed in our live classes also several times. Steel contains only iron and carbon. That is why steel is not corrosion resistant. But the stainless steel of which the utensils at our homes are made up of, they do not get corroded. We wash them regularly, they stay in contact with moisture for long period of time, but no corrosion occurs, no rusting occurs because of presence of nickel and chromium, which impart that corrosion resistance to steel. Okay, so stainless steel and steel are different from each other. If you have given the answer as a steel here, you might not get marks because composition wise they are entirely different, and the difference in composition actually results in difference in properties also. Stainless steel is better and hence it is preferred over steel. Okay, moving on to the third part of question number 4. Solve the following numerical problem. Okay, what you were supposed to do. This question was based on stoichiometric calculations based on Gay-Lussac's law, isn't it? We practiced a number of questions like this in the class. I'm going to solve this question for everyone here. Okay, later on you can match your answers. Ethane burns in oxygen according to the chemical reaction. So the best part here was they already gave you a balanced chemical equation. Otherwise, in most of the questions what they do, they give you a simple equation or they describe the equation and you have to make the equation, then you have to balance it. So this was a plus point here. You already got the equation, that to a balanced chemical equation. Now, in all such questions, what you do, based on the chemical equation, you figure out how many volumes of one reactant reacts with how many volumes of other reactant, and based on that we solve. What are they asking you to do? If 80 ml of ethane is burnt in 300 ml of oxygen, find the composition of the resultant gaseous mixture when measured at room temperature. Okay, first of all, by looking at the balanced chemical equation, we can figure out that 2 volumes of ethane requires how many volumes of oxygen? 7 volumes of oxygen. So, if you have just 1 volume of ethane, how much oxygen will it require? One second. How much oxygen will it require? It will require 7 by 2 volumes of oxygen. So if you know how much oxygen is required for 1 volume of ethane, you can easily find it out for 80 volumes. Therefore, 80 volumes, 80 volumes will require 70 by 2 into 80, isn't it? And volume here stands for ml, okay? You can, like, if it is given in ml, you can take it as ml, because it goes in that ratio only, okay? So 80 volume here stands for 80 ml. So 80 ml of ethane will require how much oxygen? When you solve this, this will come out as, this becomes 40, so this comes out as 280 ml. Okay, so when it is complete combustion of 80 ml ethane taking place, only 280 ml oxygen will be utilized. How much they added in the reaction? They added 300 ml. So that was in excess. Out of that 300 ml, only 280 ml will be utilized and 20 ml will remain unreacted. And that 20 ml you will have to add to the composition of resultant mixture. That is why I started with this. Okay, resultant mixture will not be just compound, it will not be just products. It will also have this unreacted oxygen, so you have to add it. Okay, now one second. After that, resultant mixture means carbon dioxide and water. Okay, similar ways. In a similar way, you can calculate the amount of carbon dioxide that will be formed on complete combustion of 80 ml of ethane. See, 2 volumes of ethane give you 4 volumes of carbon dioxide. So 1 volume will give you 2 volumes. That is, it is going double. So 80 ml will give you 160 ml, isn't it? So carbon dioxide will be 160 ml. Similarly, you can find out the amount of water formed and then add all of them. So the composition of the resultant mixture will be 160 ml carbon dioxide, whatever amount of water that gets formed, okay, and this 20 ml of unreacted oxygen. So if you have missed this 20 ml of unreacted oxygen, you might mix some marks. Okay, yes, very good. I was receiving correct answers from Abhyuday here. Yes. So this is how you were supposed to approach this question, and I hope none of you missed that 20 ml oxygen. Okay, moving to the next question now. From the following questions, the following questions are pertaining to the laboratory preparation of ammonia gas from magnesium nitrite. Okay, again a question from chapter number 8, study of compounds, laboratory preparation of ammonia this time they have. Okay, so write a balanced chemical equation for this preparation. Magnesium nitride is the reactant. How do we prepare ammonia from magnesium nitride? That should be known to you. Based on that, you have to give these answers. Why is this method seldom used? Yes, keep answering in the comment section. Come on, Abhyuday, Aishwarya, all others in the session. Shreya, come on everyone. I'm sorry. Yes. And how do you identify the gas formed? See beta, the balanced chemical equation here will be magnesium nitride reacts with water to form magnesium hydroxide and ammonia is given out. Ammonia will be obtained in the gaseous state in this reaction. And on bringing, like how will you identify the gas formed? We'll identify the gas formed by bringing a glass rod dipped in HCl, isn't it? Because the ammonia reacts with HCl to form ammonium chloride and dense white fumes. What will be the observation? As soon as you will bring that glass rod near to the mouth of that test tube, what will happen? Dense white fumes will start coming out, isn't it? And smell will also be one of the indicators. Okay, but if you want to see something, if you want to talk about any visual observation will be this white fumes, dense white fumes of ammonium chloride. Okay, moving on to question number 5 now. Which one, like write one use of the following alloys. Quite simple, bronze and fuse metal. Okay, I hope none of you got confused with the fuse metal. So tell me in the comment section the uses of bronze and fuse. I'm sorry, uses of bronze and fuse. Come on everyone. Bronze is used at several places, isn't it? Bronze is used for making medals. It is used for making coins. Okay, medals, automobile parts, coins, all these places bronze is used. Okay, fuse metal is an alloy which is used for making electrical fuse in the electrical circuits. Okay, basically fuse is used to protect an electrical circuit. Okay, so it is that alloy is used to make electrical fuses. Okay, next question. Draw the electron dot structures for the following. Very easy it is, isn't it? You might have faced difficulty in this ammonium ion. Dear students, I'll tell you one thing today. Whenever you draw electron dot structures, try to use dots for one element and crosses for other element. That gives you more clarity. See, if you will make the electron dot structure for ammonium ion like this, that was not for ammonia. See, nitrogen is here with 5 valence electrons, isn't it? 3 hydrogens are there already present in the ammonia. Now, there is one more hydrogen which comes in the form of hydrogen ion. So, this particular hydrogen is not going to contribute any electrons to the formation of ammonium ion. This lone pair of ammonia will be utilized. Coordinate bond will be formed here. So, when you will make the electron dot structure, here you will show only 2 dots. You will show that, like intentionally I have made circles for nitrogen here to show that both the electrons here which are shared in between this hydrogen and nitrogen belongs to nitrogen. See, here I have used cross for hydrogens. So 1 are contributed. These are the covalent bonds, but this is a coordinate bond. So like in electron dot structures, when you show it like this, it helps to give you better clarity to the teacher who is checking the paper, and this also indicates that you know the concept properly. Okay, you are not just doing it randomly. And what happens at the time of formation of nitrogen, how we will make it? So simply 2 nitrogen atoms sharing 3 electrons with each other. So for one nitrogen you can make dots, for another nitrogen you can make crosses. Both the nitrogen atoms will have 1 lone pair of electrons here, and this is how you will make the electron dot structure. Okay, now you can even show the sharing of electrons in this, isn't it? So you can make, one second, I'll erase this here. Okay, you can, you can draw these circles to show the sharing of electrons. This is how you can make. Here also, what you can do, you can make the sharing of electrons like this. Okay, and for this also hydrogen you will make this. but this will be a coordinate bond, and that will be indicated by the pattern of the electrons that you are using. Both the electrons belong to this nitrogen. This is a lone pair that is being utilized here. Okay. Third part of question number 5. Give a balanced chemical equation for the following conversions with conditions. Okay. Most of the questions, like all three of them, are from organic chemistry. Okay. How will you obtain ethene from ethanol? See here, I think a few students must have got confused that how we will obtain ethanol from ethene. No, ethene from ethanol. Even like when I read this question for the first time and I was going through the question paper, I also got confused for 1 second. Then when I read the question again, I was able to realize that they were asking me to convert ethanol to ethene, because they are asking me to obtain ethene from ethanol. They are not asking me to convert ethene to ethanol. It is the reverse of it. Okay, so I hope any one of you have not done that. Any one of you have not written the conversion of ethene to ethanol, rather it was ethanol to ethene. Okay, same here. Ethyne from calcium carbide. Monochloromethane from methane. Okay, so conversions were like this. You were supposed to write the conversion of ethanol to ethene. Here you were supposed to convert calcium carbide, that is CaC2, to ethyne, that is C2H2, and here from methane, CH4, you were supposed to write the conversion of the CH4 to CH3Cl. Okay, monochloromethane it is. So I'll show you how it is done. See dear students, ethanol, when it is heated at 443 kelvins in presence of excess of concentrated sulfuric acid, it gets converted to ethene. Okay. So this is how the reaction occurs, and this is a dehydration reaction that occurs. One water molecule gets pulled out, chemically bonded water gets pulled out, and concentrated sulfuric acid here is acting as dehydrating agent. Ethyne is obtained from calcium carbide on reaction of calcium carbide with water. When you make calcium carbide react with water, it gets converted to ethyne and calcium hydroxide is obtained. It remains mixed with the solution, like the water there. Methane gives monochloromethane on reaction with chlorine in presence of sunlight. So this is the equation, and whenever you write equations, you are supposed to give the balanced chemical equations. Now in this question, sometimes what students do, I will tell you that also. See, 1 second, we have to go back. Yeah, here is the question. When give a balanced chemical equation, it is quite mentioned. So if you give just the theory, it will not be correct. But if you just give the balanced chemical equation, you will get full marks. Okay, you will get full marks. Next question is here. Study the following observations and name the anions present in the reactions. Okay, now what you are supposed to do, you are supposed to identify the anions. In one of the previous questions, you were supposed to identify cations, isn't it? We identified lead ion and calcium ion, if you remember. Study the following observations and name the anions present in the reactions. When a crystalline solid P is warmed with concentrated sulfuric acid and copper turnings, a reddish brown gas is released. See, whatever be the positive ion, it is definitely the bromine, because reddish brown gas because of an anion. It is actually bromine, and sometimes it is because of the nitrate salts as well. Okay, so here the correct answer is nitrate, because nitrate salts on reaction with concentrated sulfuric acid. Okay, the options were bromine and nitrate, but I am picking nitrate because this particular reaction is shown by nitrate salts. Okay, so nitrate ion is in, and this reddish brown gas here will be nitrogen dioxide gas. When a few drops of dilute sulfuric acid is added to salt R and heated, a colorless gas is released which turns moist lead acetate paper silvery black. Okay, it is actually sulfide ion, okay, which is responsible for formation of a gas which turns moist lead acetate paper silvery black. And for the third one, it is actually sulfate ion. Here the white precipitates will be of barium sulfate. Barium nitrate is reacting with solution Q. Solution Q will have sulfate ions that will combine with barium ions from this barium nitrate and will result in formation of barium sulfate, which is insoluble and is white in color, so will be obtained as white precipitate. So for the third one here it is sulfate ion. Moving to question number 6 now. Define / state. Okay, you have to give the definition for electronegativity, or you have to state this law given here. Both of them you are supposed to do. So what is electronegativity? Electronegativity is a property of any element, okay, that describes its tendency. It may be talked about a functional group, like we can talk about the functional group of an atom which belongs to any element, or we can talk about the electronegativity of a functional group as well. Okay, so it is the tendency to attract the shared pair of electrons towards itself. Higher the electronegativity, higher will be the tendency to gain electrons, to pull the electrons towards itself. Okay, and Gay-Lussac's law of combining volumes is when gases react, they do so in volumes which are which are in simple ratio to one another, and they are also in simple ratio to the volume of the products, provided the temperature and pressure are constant. So simple it was, just theoretical question. Okay, the empirical formula of an organic compound is CHCl2. If its relative molecular mass is 168, what is its molecular formula? Okay, empirical formula is given. You are supposed to find out molecular formula. What is the relationship between empirical formula and molecular formula? To find out molecular formula, MF here stands for molecular formula, you actually have to multiply N to the empirical formula. Now what is N? N is a number. It is the ratio of molecular mass divided by empirical formula mass. So using empirical formula, you can calculate empirical formula mass. Molecular mass is given to you. So using molecular mass and empirical formula mass that you calculate, you will find out value of N, and you will multiply N to empirical formula to find out the molecular formula. This is how you will do it. See, empirical formula which is given to you is, CHCl2. Okay. So we have empirical formula as CHCl2. C, 12 for carbon, 1 for hydrogen, and 35.5 multiplied with 2 for 2 chlorine atoms here. So this is the empirical formula mass that will calculate from the empirical formula. Empirical formula mass comes out as 84. To find out the value of N, we'll divide the given molar mass, relative molecular mass that they gave you, with the empirical formula mass. So it is 168 divided by 84. The value of N comes out as 2. And I told you that to find out molecular formula, you will have to multiply empirical formula with N. So when you multiply this with 2, it will be C2H2Cl4. This is the correct answer. Like, this is the final answer for the molecular formula. Hello Aisha. Welcome to the session. I think you got a little late, but no problem. You can always like move it back and see the complete discussion of the paper. And you can, it slipped out of my hand. So you can always watch the previous, and you can join us right now, Aisha. Okay, and Abhyuday, very good. Your answer is correct, whatever answer you gave me here. Okay, now moving on to the next question now. Question number 6, part 2. Part 3, sorry. Okay, choose the substances given in the box below to answer the following questions. Iron, magnesium sulfide, zinc, sodium sulfide, lead, ferric, chloride, copper, ferrous sulfate. These are the options given. Only 3 of these 8 options you were supposed to pick. So to confuse you, they gave you a number of options here. Okay, the metal that will not produce hydrogen gas when reacted with dilute acids. The metal that will not produce hydrogen gas when reacted with dilute acids. Okay, it is copper. And why it is copper? Because copper is placed below hydrogen in the reactivity series of metals. It will not be able to displace hydrogen from dilute acids, and hence it will not produce hydrogen. Otherwise, zinc and iron, both of them, even lead is placed above hydrogen in the reactivity series, and hence all 3 of them will be able to displace hydrogen from acids. So out of the 4 metals which are given there, the correct answer here is copper. Okay, the compound that will produce sulfur dioxide gas when reacted with dilute HCl. The compound that will produce sulfur dioxide gas when reacted with dilute HCl. Okay, please remember that sulfite salts, various variety of salts of sulfur are available actually. Sulfate, sulfide, sulfide. Out of these, sulfite salts release sulfur dioxide gas. So, out of the given options, it is not magnesium sulfide, neither ferrous sulfate, it is magnesium, sorry, not sodium sulfide, not ferrous sulfate, it is magnesium sulfite. Okay, next. Solution of this compound produces dirty green precipitates with NaOH. When we were studying about analytical chemistry, I told you all to remember the colors, isn't it? And I told you that whenever it is a ferrous hydroxide, ferrous salts are kind of green in color and dirty green precipitates with NaOH are of ferrous hydroxide. Okay, so ferrous hydroxide precipitates will be formed by which salt here? Isn't it? So, ferric salts. Not ferric salts, ferrous salts. So, this ferric chloride will not be correct here. Correct answer here is ferrous sulfate. So, you should not get confused between ferric and ferrous. Ferric salts are always brownish in color. Okay, the color of the rust. Okay, similar to that. And here ferrous sulfate will give these dirty green precipitates with NaOH. Moving on to the next question. Come on, quickly tell me how many answers you were able to identify correct in the previous question. Aisha, Ashwarya, Abhyuday, everyone, Shreya. Okay. State one relevant observation for each of the following. Okay. To the copper nitrate solution, initial few drops of sodium hydroxide solution is added, then added in excess. Burning of ammonia in excess of oxygen, dry ammonia gas is passed over lead oxide. You have to give one observation. That means one visual observation you actually have to give. Okay. Bluish white precipitates of copper hydroxide will be formed that will be insoluble in excess of NaOH. These copper hydroxide precipitates are soluble in ammonium hydroxide. They are not soluble in this excess of NaOH here. Okay. Burning of ammonia in excess of oxygen. When we burn ammonia in excess of oxygen, we will be able to see a green flame. Okay, it burns with a green flame because of formation of nitrogen gas in the reaction. And when dry ammonia is passed over lead oxide, the color of lead oxide changes from yellow to grey because of the reaction that takes place, which converts lead oxide to lead metal, and the color of lead oxide is yellow, but it changes to grey color because of formation of lead in the reaction, lead metal in the reaction, nitrogen gas is given out. Okay, question number 7 it is now. Name the following. Organic compounds with same molecular formula but different structural formula. What do you call them? Same formula but different structures. We call them isomers of each other, and to be specific, structural isomers of each other. Even if you have written isomers, that would be fine. You will get the correct full marks. Okay. Group of organic compounds where successive members follow a regular pattern and successive compounds differ by CH2 group. As soon as you read that CH2 group difference of 1 carbon and 2 hydrogens in between successive members, I guess homologous series comes to your mind, isn't it? So, the correct answer for the second one, the B part, is homologous series. Okay, question number 7, part 2. Give reason for the following. Ionization potential decreases down a group. Ionic compounds do not conduct electricity in solid state. So, what are the reasons behind it? Ionization potential decreases down a group. When we move from top to bottom in a group, what happens? The ionization potential decreases. Ionization potential means ionization energy. Okay, the amount of energy which is required to remove the most loosely bound electron from the outermost shell of an atom. See, this happens because when we move from top to bottom in a group, the size of the atoms keep on increasing. Suppose I move from lithium to sodium, sodium to potassium, one shell keep on adding. Lithium contains 2 shells, sodium contains 3 shells, potassium contains 4 shells. So, in potassium, the electron is to be removed from 4th shell. In sodium, it is to be removed from 3rd shell. So, with the increase in distance of the electron to be given out and the nucleus, the ionization energy keep on decreasing. Okay. So, that is what you were supposed to explain properly. Why it becomes easy for the atoms of the elements to lose electrons when we move from top to bottom in a group. And the second one is ionic compounds do not conduct electricity in solid state. Quite simple, and we have discussed it in our live classes several times, that ionic compounds do not conduct electricity in solid state because the ions are not free to move. The ions remain connected to each other. They remain held together through strong electrostatic forces of attraction, isn't it? and they are not free to move. But as soon as an ionic compound is melted or it is put into water where it dissolves, the ions become free to move and electricity conduction starts. So you were supposed to explain all this. I have written explanation in as short as possible, but even if you have given a little more description, that is not a problem. Okay, the reason should be mentioned properly. The additional explanation may be less or more, not a problem. Okay, question number 7. Calculate the percentage of phosphorus in the fertilizer superphosphate. The formula for that fertilizer is given over there. Correct to 1 decimal point. So this was a numerical question where you were supposed to find out percentage composition. This was a question from 5th chapter, mole concept and stoichiometry. In that we do this kind of questions which are based on percentage calculations. What we do in this kind of questions, we calculate the molar mass, the molecular mass of the compound given. Okay, the atomic weights, the atomic masses are given for your reference: calcium, oxygen, phosphorus, hydrogen. What you will do, you will calculate the mass of phosphorus in the compound, like it will be 31 into 2. That will be the mass of phosphorus. You will divide it with the total molecular mass of the compound and multiply with 100. So you will get the answer as 26.5%. Okay, and the empirical formula of C8H18. Now no other information is given to you. How will you do in this case? In that case, if the formula is given and you are asked to find out the empirical formula, you simply have to reduce the ratio to the minimum possible ratio. That means find out the simplest ratio between carbon and hydrogen. If I divide both the numbers there, 8 and 18 with 2, I will get the ratio as 4:9, and this ratio cannot be further simplified. So this becomes the empirical formula. Okay. Answer the following questions with reference to electro-refining of copper. Electro-refining of copper, in the beginning of the session I told you that one question came from it, and while studying, while discussing the topics in our live classes also, I told you that this is very important and it might come. Okay, so electro-refining of copper. What does electro-refining refers to? It refers to purification of a metal. After its extraction, its purification through the process of electrolysis. Okay, what we do in this method, we use the block of impure metal as anode. We use a thin strip of pure metal as cathode, and as electrolyte what we use solution of one of the water soluble salts of the metal to be refined, metal to be purified. Keeping all this in mind, answer the questions. What is anode made up of? So definitely if we are refining copper, we will make anode using impure block of copper. What do you observe at cathode? At cathode you will observe that copper metal will keep depositing over the surface of cathode, and slowly, gradually the thickness of the cathode will increase. And what is the reaction taking place at cathode? So all the copper ions which are present in solution will keep moving slowly towards the cathode. After reaching cathode, they will get reduced. They will gain the required number of electrons and convert to copper atoms. These copper atoms will keep depositing over the surface of cathode, and its thickness will keep on increasing. Now you may ask me, ma'am, from where copper ions are coming in the solution? We are using solution of soluble salt of the metal as electrolyte, so that is also giving you ions. And from anode, from impure metal, the metal atoms will keep moving to the solution. Their oxidation will keep taking place. They will keep getting converted to ions, and those ions will be released in the solution. So that is how the concentration of ions in the solution will be maintained. Okay, this is what happens during the electro-refining. So these are the correct answers. I hope every one of you got the correct answers here. Okay, moving to next question, last question of the question paper. Okay, arrange the following according to the instructions given in brackets. C2H2, C3H6, CH4, C2H4, increasing order of molecular weights. So what you were supposed to do, you were supposed to calculate the molecular weights and then arrange in the increasing order. That means keeping the lowest one, or say compound with the minimum weight first and then to the highest. Okay, CH4, C2H2, C2H4 and C3H6. The next one was the preferential discharge at cathode. See, to figure out which ion will get discharged first at cathode, if several ions are competing, you have to look at their positions in the electrochemical series. Lower the position of ion, higher are its chances, or say higher is its preference. So copper, sodium, zinc and silver. Silver will get the highest preference because it is like at the lowermost position out of these ions. After silver it will be copper, then it will be zinc, then it will be sodium. Okay, so here I have written the increasing order. Okay, because order of preferential discharge it was, no? So most preference will be of silver here. Least preference will be of sodium here. Even if you have written it in the decreasing order form, that will be fine. You will get the proper marks. Okay. Moving on to the next one. Differentiate between the following pairs based on the criteria given in the brackets. Okay. So, two compounds were given, and suppose like in the first one it was cane sugar and hydrated copper sulfate. You were supposed to describe how will you differentiate between hydrated copper sulfate and cane sugar using concentrated H2SO4. You will make both of them react or say come in contact with concentrated sulfuric acid. Concentrated sulfuric acid, being a very strong dehydrating agent, will remove the water of crystallization from this hydrated copper sulfate. That will result in color change from blue to white. And cane sugar, it will turn to mass, black spongy mass of carbon. Okay, sugar charcoal will be obtained. So different observations you will be able to make. Sulfuric acid and hydrochloric acid, type of salt formed. See, sulfuric acid is a diprotic acid and hydrochloric acid is a monoprotic acid. So their like it will form different types of salts. Okay. Next question, third part of question number 8. Keep the comment section moving. Keep showing me your presence. Come on, keep commenting. How many questions you are able to get right? If you have any confusion, you can ask. Come on, everyone. Ammonia, convert the following reactions into balanced chemical equations. So, simply you are supposed to write the equations for these. What is given? Description of the reactions is given to every one of you. Ammonia to nitric acid using oxygen and platinum catalyst. So, ammonia when reacts with oxygen in presence of platinum as catalyst at 800 degrees Celsius get converted to nitric oxide. So, from ammonia to nitric oxide, that is how we go. Sodium hydroxide to sodium sulfate using sulfuric acid. So, we take sodium hydroxide, we make it react with sulfuric acid. Sodium sulfate is the salt which is formed. So, this is a basic neutralization reaction taking place between a base and an acid. Ferrous sulfide to hydrogen sulfide using hydrochloric acid. So, you have to make ferrous sulfide react with hydrochloric acid. Ferric chloride will be formed and H2S gas is given out. Okay. Next part of 8th question. Choose the answer from the list which fits the description. Okay. List is this one. CCl4, PbO, NaCl, CuO and ammonium chloride, NH4Cl. A compound which undergoes thermal decomposition, it is ammonium chloride. Amphoteric oxide is lead oxide, that is PbO. Okay. And compound which is a non-electrolyte, that is carbon tetrachloride. It is a covalent compound and covalent compounds do not act as electrolytes. Okay. So, come on. How many answers you got correct? Tell me. Everyone. Okay, I am able to see some messages here. Which nitrate has the color yellow when it is hot? See beta, it is not the nitrate. Who is this? Kanishka. They were not asking you which nitrate is yellow in color and turns white when it like cools down. Which nitrate will leave the residue which is yellow in color when hot and becomes white on cooling. So it is zinc nitrate. Actually, zinc nitrate on decomposition produces zinc oxide. That zinc oxide is yellow in color and it turns white when it cools down. Okay, Kanishka? Got it, beta? So, the correct answer was zinc nitrate. But zinc nitrate is not yellow in color and it does not turn white on cooling. It is zinc oxide which is obtained, which is left behind on decomposition of zinc nitrate. Okay, any other doubt, any other confusion? Come on, let me know how many answers you got correct. Predict your own score. Okay, Kanishka, thank you for confirming. Come on, everyone. Okay, okay. So, I hope most of you got most of the answers correct. Okay, if you like, that is all for this particular discussion. Thank you for joining me in this session. Have a great day ahead. Bye-bye, everyone.